Hello, Professor. This is my submission for data structures in LCOS. Assignment 0, the programming assessment. Wanted to go over the question real quick and then move to the code. So the main objectives of this assessment is to write a class that accepts a list of numbers on instantiation. Um, Followed by that, we'll be writing a couple of methods. The first method is to find the upper bound or the maximum value, and this has to be done recursively. And the next method is to find the lower bound or the minimum value, and this method has to be done iteratively. Um, these are methods of the class, and then we'll be creating a main function where we'll be reading the contents of a CSV file and then creating an array or list data structure and passing that data structure to the class. Moving to the code, uh, the first block contains the list of libraries we are going to use. Import CSV, which imports the CSV library, which we'll be using for reading the CSV file. Moving on to the class and method definitions, we've declared a class called Assignment0. Along with it, the initialization function, which takes in my CSV, my CSV, the list as an attribute and initializes it. Uh, so every time we call the Assignment0, it initializes a list. Uh, Moving on to the next function, the upper bound function. This function uses recursion to return the maximum value of the list, which is provided as an attribute. Here, the base condition checks the length of the list. If the length of the list is equal to 1, then it returns the only element in the list as the output. Uh, when this is not the case, it moves to the else block, where we have a variable which called next, which recursively calls the upper bound function until we reach the base condition. Um, we compare the first element of the list with the next, which is the recursive variable, and we return the greatest of the two numbers. By this we'll be able to find the maximum value in the given list. Moving on to the lower bound. Lower bound is also similar to upper bound. It accepts one attribute, one list attribute, and returns the minimum value in the list. The key difference is that lower bound works iteratively, meaning uh, it goes through all the elements in the list one by one and finds out the minimum value. In order for this to work, we have a variable called lower, uh, which takes the value of the first element in the list, my list of 0. We have a for loop which iteratively goes through my list, not including the first element since we've already assigned it to lower. Inside the for loop, we check every number in the list is checked against the lower, and the lower is updated in case the condition is satisfied. Once the for loop runs through the list, uh, the value of the variable lower is returned. Next, we use a couple of extra methods to trigger the upper bound and lower bound methods. I call this call upper bound. Uh, Here we create a variable mylist which is assigned to self.mycsv. The return statement calls for the upper bound with mylist as the attribute. We have this function mainly because we'll not be able to pass a truncated list as an attribute to the recursive function directly. So we use this trigger method to call the upper bound method. Uh, I've also listed a call lower bound, which is similar to the upper bound. However, this method is not required if we just declare the mylist variable inside the lower bound. However, to maintain uniformity, I've listed upper bound and lower bound. Moving on to the main function, we've declared a variable myCSV list, which is basically an empty list. We'll be using to store the contents of the CSV, and I've declared a variable for the file name, which is randomnumbers.csv. The next block is try and accept block, where we are trying to open the file in a read-only mode, and we are calling the csv.reader function to read the files and store it in mycsvr. So this mycsvr, we are checking this for rows. And in each row there might be multiple numbers, so we use a double for loop to catch all the numbers in case if it is present in multiple rows. And we are converting all these. The num variable by default will be in a string format, so we are using the float function to convert the number into a float. We can also do it as an int, but float is also better in case there are floating point values in the CSV. So once the numbers are converted to float, we append each number to the myCSV list iteratively. This is the try block. We have an except block in case if there is any errors. For example, file not found. We print a custom message saying that the file is not found, and to check the file path and name. We also have a catch here to check the contents of the CSV list. In case if the CSV file is an empty file without any inputs, we catch that here rather than calling the function, and print an output that the file is empty, and ask them to upload a file and try again. The next block is the else block, which is if my CSV list is not empty, we create an object which calls the class Assignment0 with the input myCSV list, which is the list that contains all the numbers in the CSV file. We have three print statements. The first is the total number of elements, which returns length of myCSV list, and then the second and third are the calls for upper bound and lower bound. We are calling these upper bound and lower bound through the trigger functions call upper bound and call lower bound through my object, which we created here previously. This is the main function here, and the final block is where we call the main function. Let's run through the code now. The code just completed running. The output lists the total number of elements, the upper bound maximum value. We see that the value returned is a floating point since we declared all values as float. 9995.0 as the upper bound and lower bound as 136.0. Thank you.